Okay, proof number 3, here we go. All right, I have the given written out. I have segment WX is congruent to segment to YZ. And my next step is just to state that the lengths are equals. Don't really have much more to do to go off that given. So I'm now going to state that the length of WX is equal to the length of YZ, and that's through definition of congruence. And again, we're stuck. So what do? Let's just kind of check in to see what we're trying to prove. So what we're trying to prove is that WY is congruent to XZ. That's what we're trying to prove, okay? So with that in mind, I think I'm going to use those two segments, and I'm going to write segment addition for those two segments, okay? So I'm going to do WX plus XY equals WY. And then I'm going to have XY plus YZ equal XZ, and that's through segment addition. Okay, so what I'm going to do here, there's actually two different routes that you can do this. All right, I'm actually going to use the addition property because I want to show you guys this step of the reflexive property, okay? So what I'm going to do real quick, though, is I'm actually going to leave a space for step 4, and I'm going to fill it in, all right, in a second after I actually do step 5. So I know this is kind of goofy, but what I want you to look at is what segment do they both have in common? Well, they both have XY, right? They both have XY in common because we have WX plus XY, and then we have XY plus YZ. So they both have XY in common. So I'm going to use the addition property for this, all right? So I'm telling you I'm using the addition property. And remember, when we use the addition property, we can keep WX equal to YZ, but what I'm going to do is I'm actually going to add XY to both sides, all right? So I'm going to add XY to this side, and I'm going to add XY to this side, okay? And remember, if you add the same thing to both sides, then the equality remains true. But here's the thing, is I actually just looked at that picture, and I recognized that both segments had XY in it, and I just kind of picked that up and put it out of thin air into my proof, right? So if that's the case, if I'm adding the same thing to both sides, we actually have to take this step where I'm stating XY is equal to XY through the reflexive property, because now I'm stating that I'm adding the same thing to both sides, all right, which means then that the equality remains true, okay? So that's the reflexive property, okay? Now, why did I do that? What are we trying to prove again? We're trying to prove WY and XZ, right? So take a look here, all right? I have WY, and let's see what WY is set equal to. WX plus XY. Well, I have WX plus XY, right? So I can take this WY and plug it in for the WX plus XY to get WY. Equals, all right? Same idea, all right? I'm trying to prove WY is congruent to YZ, all right? So I'm going to now take, look here, XZ is equal to XY plus YZ. All right, I have XY plus YZ, so I'm going to take this XZ and plug it in over here for YZ plus XY. So I'm going to have XZ. And that is through substitution. Now, if you look at what we're trying to prove, all right, we're trying to prove that they are congruent. I have them as equal, so I have to take one more step and do WY is congruent to XZ, and that's through definition of congruence. And that is proof number 3. Now, you could also do this through a substitution step, all right? So just kind of keep in mind that just because I did it this way doesn't mean that you had to.